Welcome back to AI Talks with Chris and Nita. Ready for another deep dive?
Always.
All right, so today we're looking at hyperparameter tuning. Sounds kind of technical, right?
It can be, yeah, but stick with us. It's actually pretty cool once you get the hang of it.
Exactly. And don't worry, we'll break it down so anyone can follow along. Think of it like, I don't know, tuning a guitar.
Oh, I like that.
You've got all those little knobs, right?
Yeah.
And you twist them just so to get each string to sound perfect.
Yeah, and you're essentially tuning the instrument to get the best sound. That's a great way to think about what we do with machine learning models too.
Spot on. We've got some sources here that get into all the nitty-gritty details, but the basic idea is we're adjusting these tuning knobs, called hyperparameters, to get our models performing at their best. So first things first, what exactly are hyperparameters in this whole machine learning world?
All right, so imagine a machine learning model as, say, a recipe. You've got your ingredients, which are like the data, and then you've got the instructions, which is the algorithm.
Okay, I'm following so far.
Now, within those instructions, there are certain settings you can adjust, like oven temperature or baking time. Those are your hyperparameters. They're not learned by the model itself. They're set by us, the data scientists, before we even start training the model.
So like the controls on our metaphorical oven.
Exactly. And just like with baking, getting those settings right can make or break the final product.
Makes sense. So what kind of settings are we talking about here? Can you give us an example?
Absolutely. A classic one is the learning rate. This controls how quickly the model updates its understanding as it's learning from the data. Set it too high, and it's like cranking up the oven, things might burn.
Oh, so the model's learning too fast and missing important detail.
Exactly. It might jump to conclusions without really grasping the subtle patterns in the data.
I see. And what happens if we set the learning rate too low?
Well, then it's like baking at a super low temperature. Your cake might never cook. The model might learn way too slowly, even from obvious patterns.
So finding that just right learning rate is key. Got it. What other hyperparameters do we need to worry about?
Lots, actually, but let's stick with this baking analogy for a sec. Think about how the number of layers in a cake affects its texture and complexity. In machine learning, especially with neural networks, we have something similar called hidden layers.
Hidden layers. Intriguing.
Yeah, they basically determine how complex the model is and how well it can learn intricate relationships in the data.
So more hidden layers would mean a more sophisticated model capable of capturing those finer details.
You got it. But just like with a cake, too many layers can be a bad thing. The model might become so complex that it starts memorizing the training data instead of learning the general patterns. We call this overfitting.
Ah, so it's getting too specific to that one batch of data and might not perform well on new, unseen data.
Precisely. And too few layers would be like trying to make a fancy cake with just one simple layer. It just wouldn't be able to capture all the nuances. We call that underfitting.
Okay, so finding that balance is key. Too many layers, we get overfitting. Too few, we get underfitting. What else is there?
Well, one more interesting one is the dropout rate. It might sound weird, but it involves randomly ignoring certain parts of the neural network during training.
Wait, we're intentionally turning off parts of the model while it's learning? Why would we do that?
It sounds counterintuitive, right? But it helps prevent that overfitting we were talking about. Imagine you're training for a marathon with a team. If everyone always runs together, they become overly reliant on each other.
So if one person gets injured, the whole team falls apart.
Exactly. But if you randomly have some team members sit out some runs, it forces everyone to be more adaptable and independent.
Ah, so by shaking things up a bit, we're actually making the model more robust and adaptable. Clever.
You got it. And that's just a glimpse into the world of hyperparameters. There's a whole universe of them out there, each with its own quirks and effects on model performance.
Wow, this is fascinating. I'm starting to see how these tuning knobs really can make or break a machine learning model.
So we've got this baking analogy going to help us understand hyperparameters.
Yeah, it's been really helpful. Like, it's not just about the data and the algorithm, it's also about setting the stage for how the model actually learns, right?
Exactly. And now's the fun part, figuring out what those optimal settings, those hyperparameters actually are.
The actual tuning, like finding the perfect oven temperature and baking time to get that perfect cake.
Spot on. And that's where all these different techniques come in. The stuff you sent over mentioned a few different approaches, and they all have their pros and cons.
Yeah, I saw things like grid search, random search, and then there was Bayesian optimization. To be honest, they sounded a little intimidating.
They might sound complicated, but the ideas are actually pretty straightforward. Let's start with grid search. Imagine you have a couple of those knobs to adjust. like learning rate and number of hidden layers.
Okay, so those are oven controls for the model.
Right. With grid search, we basically try every single combination of those settings within a certain range. It's like making a grid of all the possibilities and testing each one out systematically.
Sounds thorough, but I can imagine it taking a while if we have a lot of hyperparameters to adjust.
Yeah, you're right. Grid search is great for getting a really complete picture of how the settings affect performance, but it can be a real resource hog, especially for complex models.
So it's like trying every single temperature and time combination on your oven until you find the perfect one, right? You'll get there, but it might take a while.
Exactly. Now, random search is, well, a bit more random. Instead of every combination, it just picks random settings and sees how they do.
It's like throwing darts at a dartboard and seeing which one gets closest to the bullseye.
Perfect analogy. It's less systematic for sure, but it can be more efficient, especially if you don't have unlimited computing power.
So a trade-off. Less thorough, but maybe faster.
Exactly. Now, Bayesian optimization, that one's a bit fancier. It's like having a detective who uses clues from the previous searches to narrow down the possibilities.
Ooh, so it's learning from its past attempts and making smarter guesses?
Yep. It keeps track of what worked well before and uses that info to guide future searches. Really powerful, especially when you're working with those big, complex models.
It's pretty impressive, like a detective getting better at solving the case with each try.
Exactly. So those are a few of the go-to techniques. Which one you use kind of depends on the situation, how complex the model is, how much computing power you have, and how accurate you need to be.
So there's no one right answer. It's like part art, part science.
Definitely. And it's also important to remember it's an iterative process. You might start with one technique and then switch to another as you get a better feel for how the model behaves.
Like tweaking a recipe as you go along, depending on how the cake is coming out.
Perfect. You might start with a basic recipe and then change the ingredients and baking time based on the results. It's all about finding that perfect balance.
This whole deep dive into hyperparameter tuning has been really eye-opening. I had no idea how much strategy goes into this.
It's a crucial part of machine learning, for sure. And as AI keeps evolving and becoming more and more a part of our lives, understanding this stuff is only going to get more important.
Absolutely. To all our listeners out there, we encourage you to keep digging into this stuff. It's a fascinating world with so much to learn and discover. So we've really gone deep on hyperparameter tuning, huh?
Yeah, we've covered a lot of ground.
And I think the biggest takeaway for me is just how much these little adjustments can impact a model, you know?
For sure. It really shows you how important this step is in the whole machine learning process.
Yeah, it's not just about throwing data at an algorithm and crossing your fingers.
Definitely not. There's a lot of thought and strategy that goes into finding those optimal settings for each model.
Right. And as we wrap things up here, something's been on my mind.
Shoot.
We've talked about how hyperparameter tuning can make our models more accurate and less prone to overfitting. But are there other advantages? Or even disadvantages for that matter? Stuff we should be aware of?
That's a great question. It's definitely important to think about the bigger picture here. One of the big pluses is that tuning can make a model way more efficient.
Oh, interesting. So it's not just about better results, but also about saving time and resources.
Exactly. Especially when you're dealing with massive data sets or really complex models, that efficiency can be a lifesaver. But on the flip side, tuning itself can be pretty time-consuming, even resource-intensive.
Right, so it's like we're adding another layer of complexity to the process.
You could say that. It takes planning, it takes experimentation, it takes analysis. Sometimes it can feel like you're going down this rabbit hole of tweaking and testing.
But the end goal is worth it, right?
Yeah.
To have a model that performs well and can handle new data without falling apart.
Absolutely. That's what makes hyperparameter tuning so essential in the machine learning world.
This has been a fantastic conversation. I feel like I've got a much clearer understanding of how this whole tuning thing works and why it matters so much in AI.
I'm glad to hear that. It's a fascinating area, and there's always something new to learn.
For sure. And to everyone listening, thanks for joining us on this deep dive into hyperparameter tuning. We hope you found it as insightful as we did.